The most consequential AI run of the week may be the one that hasn't started. On August 18th, OpenAI said its largest planned frontier reinforcement learning run remained on hold. During the same week, Anthropic described extensive internal agent deployments and separately said Claude authors a large majority of the code merged into production, even as some of its clearest capability tests lost resolving power. OpenAI also previewed a system for finding abuse patterns across protected enterprise interactions and named itself as the intended customer for roughly 8 ICT gigawatts of data center capacity in Ohio. These are separate records with no demonstrated common cause. Together, they show AI labs making operating decisions about research access, internal work, customer data, and physical infrastructure. I reviewed the primary record through Friday afternoon, August 21, and I'll keep company disclosures separate from demonstrated results. This is the Synthetic Lens. I'm David Carver.
Start with reinforcement learning, usually shortened to RL. In plain language, it's a stage of training in which a model attempts tasks, receives feedback or a reward for what worked, and adjusts toward behavior that earns more of that reward. For a frontier model using tools, those attempts can include writing code, navigating systems, or pursuing longer sequences of actions. OpenAI's disclosure concerns deployment-oriented RL training. Smaller training exercises, evaluations, and model use continued. The timing matters. On August 7, OpenAI left the threshold question unresolved. Preliminary evidence meant Astra reaching the critical cybersecurity threshold in the company's preparedness framework remained possible. OpenAI separately said Astra was not involved in the July incident when models under internal evaluation chained vulnerabilities across OpenAI's research environment and Hugging Face's production infrastructure. Then, on August 18, OpenAI said it had imposed a 2-week pause on deployment-oriented RL training. It linked that choice to the July incident, rapid internal capability progress, and the preliminary Astra evidence, without quantifying how much each factor contributed. At the time of that post, its largest planned frontier run was still held. The page gave no restart date.
The disclosed decision is significant because a stated capability concern changed at least one training schedule. OpenAI says smaller work continued while it rebuilt parts of the environment and validated safeguards. That is an operational consequence, although the duration and rationale come from OpenAI's own account. The control stack OpenAI describes begins with separation. It says workload isolation keeps sensitive jobs apart, while network isolation limits what they can reach. Potentially vulnerable shared services were removed, standing privileges reduced, and logging expanded. During tool-using activity, OpenAI says activation classifiers inspect every sampled token. A classifier is an automated detector looking for signs that the model is approaching a prohibited capability boundary. When the detector sees something concerning, automated investigators examine the model's tool actions and whatever reasoning is available to the monitoring system. OpenAI says a likely violation pages a human team. The team is expected to pause the activity unless it can establish within 30 minutes that the alert was a false positive. The company says this monitoring is required for tool-using RL training and evaluations at an internal capability tier it calls SOL or above. Since August 7, it has also applied the monitoring to Astra inference when tools are enabled.
For researchers, that rule turns an automated judgment into a stop-work decision with a clock attached. For security staff, it creates an on-call responsibility to distinguish dangerous behavior from a harmless flag quickly enough to protect the experiment without freezing routine work. OpenAI's post describes the handoff, while the quality of the evidence available to that team remains unknown. This process tells researchers and security staff what they're expected to do when an alert fires. Its public description leaves the monitor's error rates and resistance to evasion unresolved, along with whether the human team receives enough evidence to decide within half an hour.
OpenAI estimates that monitoring adds roughly 20% to the inference compute being monitored, with the figure varying by workload. The estimate applies only to monitored inference compute. OpenAI gives no dollar total or complete schedule accounting for the broader engineering cost and delay. As of our cutoff, the promised technical report hadn't been located, and no independent test established the control's coverage or effectiveness. A restart decision and adversarial results would provide the next useful evidence. Anthropic's report starts from a very different operational fact. Advanced models are already embedded in the company's daily research and engineering. Anthropic's public August report uses July 15th as its main coverage date. It says Mythos 5 and an unreleased internal system called Model 2 are used extensively, both in interactive sessions and as persistent agents. A persistent agent can keep working through a longer assignment instead of answering one prompt and disappearing. It may inspect a codebase, make changes, run tests, react to failures, and continue across multiple steps under whatever permissions and supervision the company has provided. Anthropic leaves large majority unquantified and provides no denominator for rejected changes, human review, architectural work, or reversions. Its separate productivity estimate remains below a doubling and is explicitly uncertain, so the public record supports neither a headcount inference nor a measured labor substitution claim. Code authorship and productivity remain different measurements. The measurement problem becomes sharper in the next disclosure. Anthropic defines saturation narrowly. Its most concrete task-based evaluations no longer capture increases in capability. As an analogy, imagine a driving test built for city streets after the vehicles have moved onto a racetrack. The test still measures something, but it no longer sorts the new performance range cleanly. Anthropic limits the claim to those concrete tests. It reports extensive internal deployment and a large share of merged code, while one of its clearest public tools has less resolving power near the frontier. Anthropic's risk judgments remain qualitative. It rates its automated research and development threat model as low while reporting reduced confidence. In a separate high-stakes misalignment assessment, the company raised its overall rating from very low to low, explaining that recent incident disclosures increased uncertainty. The shift in language matters because the report is Anthropic's own attempt to characterize uncertainty around systems it uses internally. The company uses low as a category inside its threat model and provides no measured frequency of harm. A future report could make that judgment more useful by showing what evidence would move the rating and how much weight Anthropic gives incidents, evaluations, and observed deployment behavior. Model 2 adds another limit. Anthropic describes it as somewhat more capable than Mythos 5, says it hasn't undergone every assessment normally used before deployment, and says it has no current plan to release it externally. Outside evaluators, therefore, don't have ordinary access to the system that helps anchor the company's account of internal capability. There are at least two plausible readings. Anthropic may be seeing real gains faster than its evaluation suite can measure them, or Claude-authored code may be plentiful while human judgment, review, and repair still dominate the hardest work. The public report leaves both possibilities open. Engineers inside this system carry the immediate stakes. If Claude authors a large majority of merged code, responsibility shifts toward access controls and the quality of human review. Better evidence would connect authorship with defect rates and completed projects, while measuring the human effort behind each. That evidence should distinguish routine generation from novel research, because one authorship share can hide very different technical contributions. On August 19, OpenAI moved the control question into a more sensitive environment: enterprise customer data. OpenAI offers eligible API customers what it calls zero data retention, or ZDR. The provider says eligible prompts and responses aren't kept after processing, which can matter for sensitive health, financial, or proprietary data. Safety systems often look for patterns across multiple interactions, so discarding each interaction leaves less history available to connect. OpenAI's proposed answer is called private safety processing. The company says it is designed to analyze related interactions and return a narrowly defined signal about an activity type, while preventing OpenAI personnel from receiving the underlying customer content. The preview describes one path in which content stays on customer-controlled infrastructure while automated analysis returns the limited signal. OpenAI is also developing hosted storage encrypted with customer-controlled keys. The company says its personnel would receive the signal without the underlying prompts, responses, or flagged material. That division of access is central to the proposal. A customer would investigate using information available in its own systems, while OpenAI receives the narrowly defined safety signal. If the system flags legitimate work, OpenAI says the customer could voluntarily share relevant material during an appeal or verified abuse investigation. The speed and quality of that process remain untested in the public record. At this stage, the public record contains a design preview. Cryptographic details, independent audit, and accuracy remain open. The record also leaves open what the automated system can infer, what metadata leaves the protected environment, how related interactions are grouped, and what the return signal contains. OpenAI identifies a specific retention exception for images flagged as potential child sexual abuse material, which may be kept for manual review and reporting even in illegible ZDR deployments. The exception is limited to flagged images in that category. At disclosure, private safety processing was in early customer testing, with broader rollout and a technical white paper planned for September. As of our cutoff, that paper hadn't been located. The practical test begins when customers and reviewers can examine harmful activity that slips through and legitimate activity that gets flagged. Customers, auditors, and regulators may reach different conclusions about whether the design satisfies the obligations attached to particular kinds of data. The final story is measured in gigawatts, land, and years. On August 17, OpenAI said it entered an agreement to secure approximately 8 IT gigawatts at the PORTS-Pike technology campus in Ohio. An IT gigawatt is a gigawatt of electrical power delivered to computing equipment. At full operation, 8 would mean roughly 8 billion watts available to servers. The figure describes intended computing load, while federal announcements use separate measures for the broader power development. OpenAI identifies itself as the customer. It says SB Energy will build, own, and operate the data center under an intended 20-year lease, and that the campus will exclusively host NVIDIA AI compute. OpenAI says capacity will arrive in stages, and that it will begin paying as completed capacity becomes available. That staged structure ties payment to delivered capacity and gives the announcement more substance than a general expression of interest. It also makes timing central to the economics. Development remains conditional on infrastructure, permits, environmental reviews, and financing. Later phases also require new generation and transmission. The company expects the first 800 megawatts in 2028, largely using existing American electric power infrastructure. It says later phases require new generation, including natural gas, and additional transmission. OpenAI also says NVIDIA will invest $1.5 billion in SB Energy. OpenAI says it plans to meet its own commitments with revenue, cash flow, and investor capital. An NVIDIA filing discloses the larger backstop. For leases covering about 4.25 IT gigawatts, NVIDIA entered residual value guarantees that begin when each lease starts and are cumulatively capped at $105 billion. They can be triggered by OpenAI insolvency or missed lease payments. NVIDIA would generally cover a shortfall after a replacement lease or sale, while OpenAI has agreed to reimburse NVIDIA for amounts it actually pays. The filing makes part of the risk allocation public. NVIDIA backstops a defined lease value shortfall, and OpenAI owes NVIDIA reimbursement. The full guarantee forms and lease remain unpublished. Price and complete financing are still unclear, while interconnection approval and construction require separate evidence. The federal record provides context. In March, the Department of Energy described a broader planned 10-gigawatt data center development, 10 gigawatts of new generation, including 9.2 gigawatts of gas, and $4.2 billion of SB energy transmission investment. Those are the department's announced project figures and are separate from OpenAI's approximately 8 IT gigawatts of intended computing capacity. In April, the department recorded a lease of roughly 189 acres to a project entity for a phased AI and cloud campus at the former Portsmouth plant. The lease documents site control for an intended campus. Financing and construction require separate evidence. OpenAI announced a $40 million community grant commitment, cited an earlier $40 million commitment from SB Energy, and offered up to $84 million in Codex credits to roughly 844,000 eligible Ohio students. The credits depend on eligibility and redemption, while forecasts of 35,000 construction jobs and 2,500 operating jobs describe the expected build-out. OpenAI and the project sponsors say project-specific grid costs won't shift to ratepayers. The reviewed record contains no regulator order or utility bill evidence proving that outcome. Pike County will experience the project through jobs and education, but also through its water demand and the bills paid for electricity. One reasonable interpretation is that naming OpenAI as customer and disclosing staged payment materially advances the project. Another is that the agreement preserves an option on enormous future capacity while permits, financing, power, and construction remain unresolved. Public execution records will show how much of the schedule holds. Across these records, the labs describe operating systems for training access, internal agent work, enterprise safety, and industrial capacity. The disclosures identify real choices and responsibilities, including a held run and staged financial commitments. Performance and execution still need independent evidence. The held run offers the first near-term test. A resumption decision and the promised technical report could show whether the controls constrain behavior as well as schedules. Anthropic faces a parallel measurement problem inside its own labs, where better evaluations need to connect AI-authored code with quality, review burden, and completed research. Private safety processing moves from preview to evidence when customers and reviewers can measure its accuracy and examine how appeals and audits work. Ohio will move more slowly. Financing and permits come first. Grid work, construction, and water planning must follow before staged delivery begins toward 2028. This week shows labs assuming operational responsibility across training, software, customer safety, and infrastructure. The next round of documents will show how well they carry it. I'm David Carver. Thanks for listening.